Medical professionals can see hundreds of different patients every week, but it can be extremely difficult to remember all the patients you saw and assign them to an appropriate ICD code, which represents a health condition or disease that they might have. In order to do this, I wanted to build these professionals an application where they could have a scalable pipeline of data that represented the thousands or hundreds of thousands of patients that they would see in their system. Without violating HIPAA, I wanted to make sure that we could have a natural language processing algorithm that would understand these different patient notes and assign the most likely disease that an individual had. So I'm going to walk you through the process from the healthcare pipeline to the Python transformation where I used an NLP algorithm to the semantic layer where I used an ontology manager to map our different data sets together to the final application where I'm supporting these professionals. So first, I had to convert the key information that our model would use. This would be the patient descriptions of their symptoms, along with the ICD codes in a separate table and the descriptions of those different diseases. Once I transformed these different data sets and embedded all of these languages into vectors, that created something that a natural language processing algorithm would be able to understand. So after doing these transformations, I deployed them into two different data sets. You can see that here we have the vector embedding that represents in numerical formats, or rather a vector format, what each different disease could be. We did the same thing for patient nodes here. Secondly, I had to transform all of this data in Python because I wanted to create a single data set that would rank the accuracy of every prediction. So, for example, if you're a patient and you wrote down that you have a certain disease, we would have this machine learning algorithm that I built map all of your information to the vectors in the ICD codes. And that would give us a score for how accurate it thought its prediction was. And then what we could do is look at the top predictions based on a patient's description and better understand what is the likely disease or health condition that they have. So after running this Python transformation and this machine learning model, I was able to get an output table. That gives us a really good description of the millions of different patients and their potential diseases. But in order for someone to understand how to look at this data in the future, I wanted to build out a semantic layer. In our ontology manager, we're able to map out the different types of data sets that we're receiving and how they're related. And so one patient will have many different predictions, and one ICD code can also be assigned to many different predictions. So there were three different objects in here. I'm currently using the Ontology Explorer to better do some research when our end user would look at our application. So I'm going to come back to this page. In our workshop module, I've already selected someone with a certain disease. So if we look at patient number 7, we can see they had certain symptoms. And our machine learning algorithm, it's sorted by rank. It is predicting what is the most likely disease that we think this person has, or what is the relevant ICD code. In my application, I can go to a specific patient and recall some of the notes and information I had about this person. They were female, age 33 with COVID-19 symptoms. My model is recommending to me the most likely ICD code they have is U099. I can go into my Ontology Explorer and I can map that exact ICD code and get a little more information in my hospital's organization and better understand what are the different ages that people experience this at, what are the different genders of people experiencing it, and how many times is it ranked number one. And so we can see that here in our Ontology Explorer. And this lets us dig a little bit deeper to understand what the disease might look like. Thank you for taking the time to review my presentation. I've really enjoyed working in Palantir's Foundry.